Hello and welcome to Excellent Link Academy. For this class, we'll look at yet the that should be the fifth method of differentiation called the quotient rule method of differentiation. Let's look at how quotient rule method of differentiation works. For quotient rule, a variable and another will be dividing each other. So when it comes to product rule, basically, product rule, when you have two terms multiplying each other, you apply product rule, right? For quotient rule, the idea is that when you have two terms dividing each other, you apply quotient rule, right? So I'm saying that quotient rule is as a result of division, right? So it is usually it is used when two variable or terms are dividing each other. That's when you use quotient rule. So let's say I have u of x and v of x such that these two are dividing, that is u of x is dividing the v of x. From here, this becomes what a quotient rule. So the formula for quotient rule is given by dy over dx is equal to v du over dx minus u dv over dx all over v squared. This is your formula for solving problem under quotient rule. V du over the x minus u dv over the x all over v squared. By the way, this formula is similar to product rule formula, but the idea is that for product rule there is a plus in the middle but no division. For quotient rule there's a minus and what? A division divided by v squared. So this is your formula for quotient rule. So now at this point, now let's take some field problems and solve together and see how we can possibly evaluate problems using the quotient rule method of differentiation. Example 1. Let's consider example 1. Let's say I have that y is equal to 4x squared all over 6x minus 4. I'm asked to solve this one. I'm told to differentiate this. By the way, no one should tell you this is a quotient rule question. Why? Because they are dividing. So when it comes to dividing concept, use quotient rule, right? So at this point now, how do you solve this? This pattern of solving is similar to your product rule. What's my first task? I'll let this one to be u, call this one v. So we said let u to be equal to what? 4x squared. If I differentiate u with respect to x, I'll have du over dx as being equal to, if I differentiate 4x squared, I'll have 8x from general method. Also, we said let v to be equal to what? 6x minus 4. If I differentiate v with respect to x, I'll have the v over the x as being equal to, if I differentiate 4x minus 4, I'll have, if I differentiate 6x minus 4, I'll have just 6. I have this. At this point now, using what? Quotient rule. That says what? Dy over dx is equal to v du over dx minus u dv over dx all over v squared. From here now, I'll have that dy over dx is equal to v. What's v? V is 6x minus 4 into du over the x. u over x is what? 8x. I have 8x minus what's u? U is just 4x squared is my u into the v over the x. V over the x is just 6. I have 6 all over v squared. What's v? That's 6x minus 4. This is v, but I have a square here. That is a square. Then I will what? I will square it. Let's break this down. From here, the y over the x now will be equal to, I can arrange this as saying 8x into what? 6x minus 4 minus 6 come first into 4x squared all over, I have this one, that's 6x minus 4 all squared. I can choose to leave my answer this way. I'm still correct. But if I want to, I can expand. Right, let's say I want to expand. I have that the y over the x will be equal to 8x times 6x. That's 64x squared 48 possibly 48. This is 48x squared. So 8x times 6x is what? 48x squared, right? Minus 4 times 8 is what? That's 32x, right? Minus 6 times 4 is 24x squared all over 6x minus 4 all squared. From here, I can see x squared, they are like terms. So 48x squared minus 24x squared, that will give me 24x squared. So I have the y over the x has been equal to what? 24x squared. Repeat this down, minus 32x all over 6x minus 4 all squared. So this is my answer after solving for this particular problem using quotient through method of differentiation. This is how it works.